So you often see me working with variable speed drives. In this case, the Control Techniques drives from Nidec Drives. Today we're going to talk about the PC software. So I've got it opened up here. The software is called Connect. Okay. So you download it from the Nidec Drives website and install it. It's free, there's no registration needed. So I've got it connected to a C200 using the USB to 485 cable, and there's a couple of options here. I can scan for the drive using either Ethernet or the serial RTU network or Bluetooth, because the drives with Bluetooth keypads can connect to the PC using Bluetooth. Over here in settings, got our COM port selected. If I pull it out, we should see one of them disappear. Yeah, so we know that that's COM 4. Then I'm just going to turn these off, and I'm going to turn COM port 1 off. Okay, so if we were to do a scan and look for the drive, it's going to use only that COM port for the search. Now in open, there's obviously your project list from the past. Then in new, it brings up all the products that you can program through the software. Now in our case, we're working with the Commander C200. You got to then tell it which size drive it is. Now once you've selected the drive over here and you're unsure the model, it will fix itself when you go online. So let's show you how you do that. So I'm going to say OK, and now the dashboard has appeared. Now if I go online now, it's going to connect to it or not. Interesting. Let's see if we can find it from a network scan. Oh, I know what I did wrong. Let's go to settings here. One drive found. COM 4, yeah, that was my problem. So what I need to go here to my settings, change the COM port to 4, set latency to 1 milliseconds, and say OK. So now I should be able to go online. Now it has found a drive with a different current rating. So I'm going to say OK. So now if I go offline, set model, it's changed it to a 4.2 amp drive. OK. So the online and offline is this button over here. There's a couple of things to remember when connecting to it. If you are connecting to a drive that was previously used, you should think of making a backup of what's currently on the drive. But I'm getting ahead of myself, so firstly I'm going to go offline so that we can go over here and give the project a name. So that would be C200 training, like that. Okay, so that's now over there got a name for the project. Now you can have multiple drives in the project. Now I'm over here going to give it a name. I'm going to say my drive. Okay, so now let's go online again. Now that blue over there indicates that we're online. So those are the two places that you can click online and offline. Now in parameter files is where backups live, over here in the tree. So if I say new parameter file and hit enter, I can add the extension upload original parameters. Let's get rid of that 6 like that. Now it's automatically going to upload from the drive and create a .parameter file. So now you've got to back up what's on the drive. So now if you were to change the drive to factory settings, you've got a record of what was on the drive. That's very important. If you want to back in file operations, let's go out again. I think you need to be offline. File, I wonder where they hid it. There should be a place to export the project. Tools, interesting. Another thing in view is help. So while in parameters, if you want to see what that parameter does, click help, then that appears over there. Now if you've got space on the screen, it's useful to dock it over there like that. Let's bring that back. Help. We should be able to dock it. It can stay there as well. So in here, when you click on the parameters, it brings up the descriptions over here and so on. So there's your help file. So that's built into the software. Okay. So I'm just going to hide that. What were we talking about? So we've got our original parameters, but we've now defaulted the drive. So over here, what we've had opened appears as a list. So there's our dashboard again. Now there's a couple of things you can do over here. Tile, that tiles it like that. Okay, that really confuses the issue. Here's your drive properties. So it's a 0.75 kilowatt 200 volt 4.2 amp drive. So I'm going to hide that. Bring that back. What I want is the dashboard over here. Now okay, that we want to hide. Aha, we want to be in home, like so. I want to compare with defaults. So what I'm going to do is put those parameters back into the drive, and we'll be able to see what was in the drive previously. Let's just do a save. Oh, we're offline. Let's go back online. Okay, now say download file to drive. That's better. So now we're actually downloading to drive. Okay, let's do a save. So that saves it to the EEPROM in the drive. Okay. So now that ribbon will stay there because I unchecked minimize. Now compare defaults. It's going to upload from the drive, and it's going to create a list of everything that was set on the drive. So let's have a look at what it finds. So there's two ways of looking at this. The basic view over here, which shows that we've got those values changed in the drive. It shows what I've set into the drive, and then it shows the default value, the original factory value over here. Non-setup parameters produces longer list. So that's everything that's been changed in the drive is shown in that list, like that. So if I now go copy, this is copied as a text file to clipboard. So if I want to put that into a Word document, bring that over here and hide Control V. It produces this list over here. Control Z, paste options. So it looks like that. Also, you can obviously print it. And then you can PDF export it as well. So that's useful if you want to keep records, print records, or email somebody this list. So that's how you do that. Okay, so this is already beginning to get a long video, but that's fine. So in the drive, that's your quick access menu over here. You've seen me access that on the keypad. So there's a drive configuration and log voltage. So that means it's in terminal control. As your axon decel rate, is your motor details over there. We've got our boost, which we were playing with yesterday. and a couple of other things. Menu 0 is basically a collection of stuff from these other menus over here. Okay. The brake controller is enabled on this drive. That, in other words, known as the crane application, where this works holding brake on the hoist motor. So when you set that to relay, like that, it changes the behavior of the relay. So in menu 8, which is your digital I/O, your brake by default is going to be indicated. That relay contact that normally open is going to close, indicating drive healthy. If I come back here, change it to relay, you can go back to menu 8 over there, drive healthy. That should change. That's interesting that it's actually not doing that. Let's have a look here. So it is set to relay. That should be indicating something else. It should be indicating the status bit over here. Brake control release. Now if I change that to a large list, the text gets bigger. So when I turn the drive on, we can see that bit coming on over there. Similarly, in digital I/O, you can also change the view. You can view the inputs and outputs. So when I give it a run forward, we can see that terminal 12 has come on. Terminal 12 addresses the run forward bit 630 over there, which is menu 6. So that's a run bit over here. So how it works is the I/O comes in, then it gets addressed to bits elsewhere in the drive, in and out. And the same applies to analog I/O. Our potentiometer over there comes in on terminal 2. So if I grab that and I turn it down, you can see it changing. And that then writes to menu 1, which is your frequency references thing. So for many people this is a bit of a challenge to get their head around. Some people refer to it as pointers and so on. One way of doing, sort of getting your mind around this, is using the block diagrams. So menu 0 is basically an overview of what happens in the drive. Analog reference comes in, digital reference comes in, here's your ramps, there's your motor control, and then finally your output to your motor, and then there's your current control over there. That is a collection of everything that's happening elsewhere in the drive. So if I click on menu 1, I'm going to see that block over there, and clicking on that block brought up that one, frequency references. It's the same thing. Okay, so over here we can see that terminal 2 in menu 7 is right into 136, and we can follow that progression through to here, where this and a value of hertz is the reference. We can just follow that along further to where things like allow bipolar references, in other words negative frequency references, can be turned on and off. Skip frequencies for resonance avoidance and so on can be controlled. Here's your ramps, how fast you want the thing to accelerate. From there we go to menu 3, which in this drive is a fairly small menu. You've got your 0 speed threshold, your 8 speed detection and that sort of stuff. Over there, that then sets bits in your status menu. Over here, menu 10. Here's your current limits over here and your current gains. Here's your motor control. Now, some of the stuff you're not going to, some of the stuff in menu 5 that you don't see in this block over here. Stuff like the motor details. If you go back to parameter list, here's your motor details, the 1.3 amp motor, 1310 to 20 volts, and that sort of stuff. So some of them, the block diagrams are sort of abbreviated. There's other user functions as well. The logic function, there's an AND gate with a timer. There's 2 of them. And that over there is for when you're using a real-time clock. You can connect a real-time clock to the keypad to this, and you can use it for pump or fan or whatever control, start to stop and start it using a real-time clock keypad, which is an external keypad in this case. I'm going back there. Motorized pot or an electronic pot. If you want push button control for faster and slower, you would use this. The binary sum over here, which will give you a decimal value from 3 binary values. Now the way this works is you don't just click on that and get a binary sum output. Well, in this case you do. What you could do is turn that off. I'm getting ahead of myself here. Go back to 0. You need to address this to a register, so you can use one of the application menus. So you go over here, you look for something which has got an integer. So let's use a read-write integer, 1911. Go back here, 19.11. It wants a comma. Comma 11. It's accepted it. Now when I save that, it didn't, oh, I put in a 0. Not too happy about that. .11. 18.011. Yeah, it wants a 0 before the 11 because there's 3 decimal places. So now it's happy. So now when I set a bit high, it's going to show the binary value over here. In this case it's converting it to a 16-bit value. It's doing some strange maths. .021. Yeah, so it's what it was doing was converting it to a fraction of 50. It's using 50 hertz as a it's converting that. It's dividing it into 50 hertz. So we got 3 divided into 50 hertz, it's 21. So doing some weird maths. So it's something you got to be careful about. And when I was writing it to a 16-bit register, it was converting it to a 16-bit value that would represent 50 hertz. That's how we saw the big number. Yeah, so there's a couple of things that can trip you up here. Anyhow, status and trips, these are bits. Okay, so drive active is going to show us that we're going to drive run. At 0 frequency's gone off, and then at frequency is on. So these are status bits. Your trip history is in here, overcurrent and so on. I'll get to that as well. You can, out of this software, clear that history. One more thing to note in menu 6 is that you have how long this drive been running for. So you've got an hour meter on the drive. So you do have to do a bit of maths here, because it uses day, month, year, which you're going to convert to hours, and then that is 5 hours, 19 minutes and 25 seconds. But you ought to take that into consideration as well. You add those two together. And I change it to powered. We've been going for 44 minutes with this tutorial. Let's go back to let's have a look at these tools and wizards I was talking about, the drive trip log. So that looks like that. Overcurrent, user program, IO overload. IO overload is what the original owner of the drive did. And user program is what I did. And then overcurrent is when I was faffing around with the thing, playing with some loads, and I had capacitive load on the output, and it caused overcurrent trip. Now I can hit clear log, and those go away. So that's how you clear the trip history on this drive. And that can't be done from the keypad unless you know the code, because it's a serial command. But from the software you can clear the log. If the drive is tripped, you would use this reset button over here. Now let's wrap up with a few more things over here. In wizards, you got these quick setup things. It sort of takes you step by step through the thing. So that's motor setup. If you have a temperature sensor in the motor, you tell it which input you're using and what type of, whether it's a thermistor or just a contact type temperature sensor. Feedback setup we're not using, and then custom, you can create lists over here, create custom lists for yourself, then finally send to drive, and it then downloads. Right, so what else have you got? Auto tune. That's important in terms of the stator resistance and inductance measurement. Now stationary is going to measure those two for you. Rotating will also calculate power factor for you. So it warns you that the motor is going to spin if you're doing a rotating auto tune. You can select the direction and so on. Now if you know where to find that stuff in the parameters, you can do it from here as well, and choose your auto tune type over here like that, and you can also start it from the software, run over there, starts the drive from the software. Now if I were to try and click on run forward, you'll see it goes on but goes off again because the digital input is overwriting that bit. So what else have we got? There's your analog I/O setup. Digital I/O setup is basically just showing you the block diagram, which is a duplicate of this over here. Speed references, that's a simplified version of menu 1. Ramp setup looks like that. This is a duplication once again of the stuff over there. You can, with the SD card adapter, back up stuff from the drive onto an SD card. You can also program the drive from an SD card. You can also load a PLC program onto the drive from an SD card. Now this over here is PLC controlled motion. That is stuff that I've not worked with yet. I'm actually not sure how that works. The software guys spend more time with that than me. You've got solar pump solution. I think I just caused the thing to hang. Yep. Oh, here we go. What happened here? This drives firmware. Oh yes. You need certain firmware versions to work with the solar pump solution. Okay. Because you can feed DC into these drives and use it as an inverter for a solar pump to run a conventional 3-phase submersible or non-submersible pump directly off solar. Very neat. If you have two analog inputs configured to the same parameter, assigned to the same parameter, the drive will trip and give you an error. If you're trying to find out where you messed it up in the settings, it'll appear in this list over here. So currently there's no conflicts. Parameter reference guide. That's quite a useful thing over here. There's your descriptions of your parameters. So what else have we got over here? I think we've pretty much gone through it. Parameters, block diagrams, that's a duplication of what's in the tree. Project overview. Interesting. Okay, now we're back online. Although the blinky light on my cable showed that I was online. If you in the PLC software have written a PLC program for this and compiled it, the compiled program can be downloaded to the drive using this software. And if there's a PLC program on the drive, you can erase it from here as well, at your peril obviously. You got to know what you're doing. You've got to be sure that you have what's on the drive on record before doing that. Because the one thing you cannot do is upload a PLC program from this drive. If you want to work on it, you need the original source code, so be aware of that. So there must be a way I'm trying to remember how you export the product, because if you need to send this to somebody else, you need to there's two ways of doing it. You can, in your file explorer, let me just find it. Going to connect, so it lives in control techniques, connect, and then training, C200, C200 training. What you basically do is you select that folder and you zip it with your favorite zipper, and you send it to your recipient, and they then put that folder into their control techniques folder. Then when you go to open, it'll populate over here and it'll be as C200 training like that. There used to be an option to export this as a project file, a .prz file. And they put that somewhere and I can't find it. Then yeah, that's not really relevant at this stage. So A lot of stuff here in the tree is a duplication of what's upstairs and so on. So I think that's going to wrap it up. That's the PC tools and how that works. And it gets quite complicated. So this was basically an introduction to how to do it. How to go online, how to use the file operations and that sort of stuff. Our video is getting to about an hour here now, so I think it's time to wrap it up. Ladies and gentlemen, thanks for joining me here today for this talk on the PC tools. It is interesting and relevant to some, and I hope you found it interesting and useful. For the rest, take care. See you next time. Cheers.